Here's another common physics electric field problem. Two charges, find where the electric field is zero. So pause the video and try doing this on your own. And once you've done as much as you can, hopefully you can do the whole thing, come back and check and see how you did. Okay, I assume that you're back. So what I would do if I were just, I know the answer to this problem, but if I were just beginning, I would look for places where it might work. So let's say I'm going to go in the middle, see if the electric field could be in the middle somewhere. We're going to have a field vector toward the negative charge and one away from the positive charge. That can never cancel, so it can't be between the charges. If we go over here, the vectors will be opposite. The positive charge will have an electric field vector away. Remember, we're talking electric field. There's no charge at this point. So we're just talking about the electric field due to the positive charge. That would be E1. And an electric field due to the negative charge would go toward the negative charge, E2. And you might think that these could cancel, but when we look closer, we see that we're closer to the larger charge. So E1 is always going to be much larger than E2, and this won't work. So the place we need to be is over here. E1 will be in this direction, and E2 will be in the opposite direction as it goes towards a negative charge. And these could cancel because E1 has a bigger charge, but it's further away, so that might compensate for the fact that E2 is smaller but closer by. So what we're looking for is we're looking for this unknown distance, and we'll just call that x. We're looking for x. Now, in your solution, it's not just getting an answer. It's important to know how to write down the solution. So we could start with the statement, the sum of the electric fields need to be zero, or recognizing that in order to be zero, the magnitude of E1 has to be equal to the magnitude of E2. I could make the statement that E1 magnitude equals E2 magnitude. I could have gotten this from the first equation, right? Because if I write this out, I would have the sum of the e's equals vector E1 plus vector E2. And so those have to be equal and opposite in order to sum to zero, which would lead me to this equation here. All right, so we're talking about absolute values have to be zero, so we can ignore the sign on the charge. And let's be careful. We're here at this position, E1, and we go to the equation, right? It's K, Q1 over the distance from E to Q1, okay, squared, so that's D plus X, that distance from the point to the charge, D plus X squared. And that has to be equal to, put the absolute value signs there just to remind you that we're not paying attention to sign. On the other side we have K Q2 divided by the distance from the point to the charge. Oh, that's just X squared. Okay, I'm getting short on space, so I'm going to shortcut the algebra. I'm going to divide both sides by K. I'm going to rewrite this. I'm going to go over here to get more space out of this. I'm going to have Oh, and then I'm going to cross multiply. Just let me do that. I'm going to multiply both sides by x squared. Cross multiply really means multiplying both sides. And multiply both sides by this parentheses, d plus x squared. And when you clear out, oh, and then which charge is larger? Q1. So this is getting messy, but try to follow it. I'm going to divide by Q2. And this and that go to 1. And I think I've canceled everything. And if you see what remains of all the cancellations is, this is the only term that remains on this side. And this, and the x squared remain on this side. So what we have is, and these are absolute values, Q1 over Q2, x squared equals d plus x squared, d plus x whole quantity squared. And we know from the example we did in class that rather than multiply all this out and get complicated, we'll just take the square root of both sides of the equation since there's only single terms. Note that Q1 over Q2, looking at the numbers or the symbols, it's a 4-to-1 ratio. So we're going to take the square root of 4x squared. So the 4x squared square root becomes 2x. And the square root of that quantity in the brackets becomes d plus x. I subtract x from both sides. And I get x equals d. So let's go up and look at that. Our x equals d. Let's see if it makes sense. So this point to this charge is a distance d, and from this point to the bigger charge is a distance 2d. That's 4 times bigger. It's twice as far away. That makes it 4 times weaker. So the larger charge is compensated for by doubling the distance, which gets squared. Okay, so this result does make sense. In fact, if we had saw the 4-to-1 ratio, we might have guessed that before we even did the problem. You might be able to solve that one in your head.